Okay, finally let's consider the problem number 17, where we need to find, which we will split into two sub problems. And in the first problem we will need to find the velocity of the block with a bullet inside of it. Okay, so what happens? We have a bullet which hits the block, gets stuck in there, and then the bullet and the block moves together. So we want to find the velocity of the block just after this collision. Okay, so it is a collision problem. It's an elastic collision. We have an object 1 which is at rest. So the block is at rest. It has the mass of 3 kilograms. Its velocity, initial velocity is 0. So we have the bullet with the mass of the bullet is 0.02 kilograms. So this is the block with a capital B, the bullet will be with a small b here, 0.02 kilograms, and the velocity of the bullet is 300 meters per second. So to have definite direction of the x-axis, I will show it. I need to find the final velocity of the bullet and the block. So they're moving together. Okay, just right after the collision. So this is an elastic collision, and therefore only the momentum is conserved. So the mass of the block times the mass of the bullet times the velocity of the bullet plus mass of the block times the velocity of the block in the initial state is the same as what we have in the final, but in the final we have the system together. So I just sum the masses together times V final. And also I can take into account that the block was at rest in the beginning, so this term is 0. And from here I will be able to find the final velocity of the block. It will be mass of the bullet, so solving this equation for V final, it will be mass of the bullet divided by mass of the bullet plus mass of the block times initial velocity of the bullet. Substituting the numbers, I will obtain 1.98 and 7 meters per second. So this is the final velocity of the block. Just right after this collision. Okay? Just right after this collision. So now we will consider, so we will remember this number. Okay? We will remember this number. Just right after the collision, the velocity is given by this number. Okay? So now what we have here, we have that the block go as shown over here, it is suspended on the string and goes up, okay, by some amount of h, and then it stops, and we need to find this h. Well, this is the conservation of energy problem. So we have the change in the kinetic energy plus the change in the potential energy, and it is given by the work done by the non-conservative forces, which we are said we can neglect. So it is in the sum it is 0. So the change of the kinetic energy, it is given by mass of the system, okay, times the velocity of the system in the final state squared over 2 minus mass of the system times the velocity of the system in the initial state squared 2 plus mg times delta y by delta y in this problem is just h. And in the sum, this is 0. We know that the system stops at this point. It stops. So the final velocity here of the system is 0. So this is 0. And this is why we can solve this problem for this known h. H will be given by this equation. Okay, so now the next point is to figure out what is this velocity of the system initially, but we just found it. So this is the velocity of the system initially for this second part of the problem. Okay, so, oh, by the way, so mass of the system cancels, of course, sorry. Okay, so velocity of the system we just found, so we can just substitute everything into this equation to get okay, we're using our calculator. To get 0.201 meters.